Okay, today is November 30th, 2020. Today I would like to discuss or talk about how do you, I guess so far we're talking about post-formal operations stage. I mean, Piaget talks about stages up to formal operations. We're saying there's a new stage that appeared within the last few hundred years and that it's had a big impact on innovations since that time. And so we should, I want to say something about what that stage is. I mean, how do you tell whether somebody's in that stage or not. And to begin with, we need to talk a little bit about the previous stage, the formal operations stage. And formal operations, I'll go back one more stage. Concrete operations are reversible, to Piaget, are reversible operations that are applied to physical reality, like moving objects and getting a sense of, basically you're applying operations to objects. And eventually you can, in formal operations, you can apply operations to operations. And so that makes them somewhat independent of reality. And then that allows you to use them to build theories and systems. And so, whereas I see the formal operations, what you have at the beginning of the formal operations stage, it's these elaborated systems and theories that are the end result of the formal operations stage. And the next stage then takes these theories and systems, and instead of being what were the accomplishment of formal operations, are now the building blocks for the next stage. The next stage then would involve relationships between and among the systems that were developed in formal operations. And one peculiar characteristic is that once you have systems of systems, which is what we're talking about, you can think in terms of sets, and you can think of sets that include themselves. If I talked about a set of all sets that contain themselves, that would contain itself. And there's sort of a paradox for when you get to the set of all sets that do not contain themselves. So that's somewhat of a paradox that arises at this level. And so if these are the characteristics, where do we see these in reality? And if there's going to be any place where we see this stage in action, it would be in the work of the man whose name is synonymous with genius, and that is Albert Einstein, and his work on the theories, special and general theories of relativity. And these theories involved two things. One, focus on observers, and two observers, say, that are moving relative to each other. but neither of them necessarily, well, you have these two observers, and you think about how the laws of physics would look to each of these two observers. And then Einstein postulated that or reasoned that the laws of physics should be the same for both observers. And in order to make that basic proposition true, he had to change or go counter to our intuitive sense of space and time and causality and mass. So it was quite a commitment to that particular proposition. But for our purposes, what we can notice is that he was looking at the one system, law of physics for the first observer, and another system, the law of physics for the other observer, and then saying they have to be equal. And the other thing is the importance of the observer in formulating this, and the discussion of the observer is a form of self-reference. So we see in Einstein's work evidence of this type of reasoning, and we're going to say that type of reasoning, this setting up relationships among systems, was not present, say, when Newtonian mechanics or classical mechanics was set up. And up till about the time relativity came into existence, the assumption was that there was one perspective about which the laws of physics were centered, and the way you did some translation to figure out what the laws of physics would be in other systems, and for observers moving relative to a stationary observer. And so that was an assumption before Einstein, and so there was no need to compare the different laws of physics for different observers. There was only one set of laws of physics, and then everything was what the other observers would see, would be then derived from that. So Einstein changed physics using two of the principles that characterize formal operations. All right, so that's enough for now. Thanks a lot. Bye.